Hi, hello, Calvin. Hey, with you guys' just lost my word. Interest in having a meeting or request for having a meeting or booking a meeting. And since you told me the situation that you were looking at, I went ahead and made this educational kind of teaching review video, just a reminder of certain what ends up being, as you guys know, just some basic algebra rules, some basics of math rules. So even though it is a science formula, it comes down to math. And that's just a reminder how you can't separate math and science for very long, especially on the research or the measurement side. But we'll just talk about a few things here. I did pull into, as you can see, let me get a pin here. As you can see, I did pull, all of them in that you missed, and of course there was one the same, as you know. And so what I did there is I just plugged some different numbers in just to, again, go over how to do it, and then different numbers, just so they have a different problem to work with. So we're going to start by kind of going over some key points here. And you can see I got 3 of them. And so one of the problems, one of the questions, when you're using it looked like when you're using that 1/2 that you weren't sure of what to do with it. And as I said here in this note, it's pretty simple. You can either multiply by 0.5, 0.5. And I've got that wrong. That is not, shouldn't be. No, I got an extra 0, and let me fix that real quick. Let me close this out and edit this. I didn't notice that when I was looking up everything, but we want to edit this. Let me take that. There we go, by 0.5. I had an extra 0 in there. Sorry about that. Or you can divide by 2. Let me get my pen back here. Okay, or you can divide by 2. You get the same result either way, multiplying by 0.5, which is half, as you know, or dividing by 2, which cuts something into half. So that's how you handle that. So in the formula, when we're looking at this part right here, that's how we're going to handle that. And it doesn't matter either way. That's whichever's easiest for you to do. The second part, it says volume squared, not volume, velocity squared. And the reason why I wrote them all in these little 2's is because when typing in this software, it doesn't recognize, it doesn't give you a way to do exponents. And I don't want to just type a 2 out beside there. I wanted to write it if it looked exactly like it needs to. So that's why they're all handwritten, or I should say mouse written, mouse drawn. But it's simply, as you know, it just simply means you take that number and you multiply it by itself. So for example, over here, if I have a 4 squared, that's going to equal 4, and I started doing something else, 4 times 4, which of course you know is 16. So that's the idea of that. You just take that number and multiply it by itself to get the answer. And the last one, and where the algebra stuff really comes into play, when you're going to solve for one variable, and I put those down here, you got to move everything over to the other side and just do the opposite sign. So for example, when you're just solving for kinetic energy, which 2 of the problems do that, actually it might even be 3, it's just a straightforward formula. They've given you that one. But if you have to solve for the mass or the velocity, then you simply just move everything over to the other side. And so if we're solving for mass, we move the velocity squared over, and since on this side we multiply, we're going to multiply it, as in right here, now we have to divide it. And it's the same thing with the mass. And again, I outthought myself here. Let me get rid of this pin here and fix this as well. That should be, let me make sure of this. we're going to move the mass over, we're multiplying. So yeah, we're going to divide right there. That should be a division sign right there. All right, now I think I got all the bugs worked out. But actually, that one doesn't come up. I don't believe that one came up. I don't think we ever solved for velocity. But that's how you do it. All right, let me close this out and move this down. And we will get started with some problems here. All right, and you can see I've got the problem here, and I've also got it worked out down here, but I will go through step by step on how to solve that. So let me get my pen back here. So in the first problem, we got a velocity of 8, and we don't need that message. Velocity of 8 and kinetic energy of 480 joules. So we simply plug those numbers in, and you can see those are right here, and they are right here. And of course, so now we're going to be solving, okay, for mass. So we're going to use this one right here. We're going to move everything else over. Okay, so we got the 480. If we go to the next line, we got the 480 equals the 1/2 of the mass times, now it's 64 because we took the 8 and squared it to get 64. Okay, now we got to take that 64 over to their side, and since on this side we're going to multiply it, we have to divide it, okay, over here, which is what we did. Yeah, right here, which is what we did right there. So now we take the 480 divided by 64, and that gives you a 7.5. Okay, we still get that 1/2 to deal with. So since we have 1/2 times the mass on this side, we got to move that 1/2 over to the other side. And since on this side 1/2 is a fraction or dividing, you're going to be multiplying on the other side. So when we take it across the equal sign, we do the opposite thing, and on this side we're dividing. So over here we have to multiply, and 7.5 times 2, as you know, is 15. So 15 would be the answer for that. This is problem. This is the first attempt, and it's the second question. This is the one that you actually identified as the one that you would wanted help with. And that is how you solve that. It's simply plugging in the numbers, okay, taking care of any exponents that you need to, and then moving everything to the opposite side and doing the opposite sign. Okay, so if we look at our second problem, now we're right here. Okay, we've got a mass of 0.5 and a velocity of 10, and they want us to find what is the kinetic energy. So this is probably the easiest of all the types of problems, because now you got to plug everything in, or you plug everything in, and since everything is on the side that it needs to be, you won't have to move anything. Now it's just straight math. So we plugged in the 0.5 for the mass, we plugged in the 10 for the velocity, and now we just did our math, taking 1/2 times 0.5. So you can either divide by 2 or you can multiply by 0.5, and either way you get to 0.25 because that is half of 0.5. And this 100 is simply 10 squared, which is 10 times 10, 100, and now you're just simply going to multiply those two to get 25. And I think in your answer you had 50, so I think what you did is you didn't do this part, or wasn't sure how to do that part, so you just carried down the 0.5 and took that times 100, which would have gotten you 50, but that is leaving out the dealing with the 1/2 aspect of the problem. So that is part 2. Let me close this so we can push this up just a little bit. Yeah, we don't need to see the key points any longer. I think we've got the idea down now. So now this is, we're right here, and this is attempt 2, question 2, which is the same as you can see, attempt 1, question 4. And so instead of working the same problem again or just losing a potential example, I brought it in, and we're just going to change these numbers from 0.5 to 2 and from 10 to 5, just to give us another problem to work. So again, here's our basic formula. Kinetic energy equals 1/2 times the mass times the volume squared. Okay, so now we're just going to plug numbers in. We plugged the 2 in for the mass that we had, and the 5 in for the velocity. And now we just simply do the math. 1/2 of 2, as you know, would be 1, and then 5 times 5 squared, would be 25, and then that's a simple math problem there. 25 times 1 is going to be 25. So that is how you work a problem when they want to know kinetic energy. Plug everything in, handle the square properly, handle the half properly, and you will get to a good answer. So let me close this out and scoot everything up so it's towards the top. There we go. And now for our last question, and I'm pausing here because, yeah, there it is. Okay, so this, I don't know where, I thought I numbered all these. So this would be, I think this is attempt, I think this is attempt 1, question 7, but I'll double check that. All right, so, but again, our question is, we've got velocity at 12, we've got a mass of 600, and what is the kinetic energy? And that's helpful because that's the easiest way to use this formula, because everything is on the side that it needs to end up on, and so therefore we're just plugging in the numbers and responding to it. So we're going to plug in the 600 for the mass and the 12 for the velocity. Okay, and then we're going to square the velocity. 12 times 12 is 144. And then 600, and half of 600, of course, is 300, as you know. So we've got those two numbers. And so now again, you just multiply those two, and you get 43,200. And again, I think the situation with your previous answer is dealing with the half. I think you just wasn't sure what to do, so you kept the 600 and took the 600 times the 144 to get a different answer. So that's the idea with the math side of the questions in your quiz. It's handling the square properly, handling the 1/2 properly, and if needed, moving things to the opposite side of the equal sign and doing the opposite sign. All right, so for the last part of this, we had 2 questions, okay, just about concepts of potential energy and kinetic energy. So I brought those in, and so we could talk about those. And the others, I took out the answers because it doesn't matter. We didn't need to see what all our choices were. All we needed to see was how to work the problem. And if we can understand that, then we can work any problem properly if we understand the process. But these, I left the answers in so we could talk about what made them true, what made them false. But I got a little diagram here, and this will help us with the first one. But if you think about the idea of potential and kinetic energy, for one thing, you have to remember that they're exactly the same thing, just at different points in the continuum. If a ball is sitting on, or a boulder or a ball or whatever is sitting on top of the hill, at that point in time, it is 100%. Let's get a different color here since I used red. 100% potential and 0% kinetic. So it's at its greatest potential energy, sitting still at the top of the hill. And at the bottom of the hill, okay, it's come all the way down here. Now it's 100% kinetic and 0% potential. In other words, it's used up all its potential energy, and now it is completely kinetic energy. It's also at its maximum velocity and maximum acceleration. It's going as fast as it's going to go at that point in time. And then as it passes through this downhill section, as it gets a fourth of the way into the trip, it's now to 75% potential, 25% kinetic. When it gets halfway, it's 50-50, and I could put another X here, and now it would be 25-75 potential to kinetic. In other words, the further down it goes, the kinetic energy increases, the potential energy decreases. But the opposite happens as it tries to go back up the hill as much as it can. Most things under their own power will not make it back all the way up to the hill. But if it did make it back all the way up to here, okay, and then get to a rest, again, it would be 100% potential and 0% kinetic. But as it goes up the hill, now the potential energy increases because it's slowing down, and the kinetic energy decreases, again, because it's slowing down. So I could have put another one here, just didn't want to be cramped, but we can put potential to kinetic, okay, and now it's 25 to 75. And as it goes up, it gets to the halfway point, it's 50-50, and it gets 3/4 the way up, it's now potential 75, kinetic 25. And I should have put lines in there to make it easier to see the ratio. So that's the idea of converting or changing from potential energy to kinetic energy. So now let's look at some of our options. So option 1 and option 4, okay, are the same thing, just said in reverse. Objects have more kinetic energy than potential. Objects have more potential energy than kinetic, and both of those would be false because that's the same amount, okay, and it only changes based on its position along the gradient. So it doesn't have more or less just because of the object it has. Like a bowling ball doesn't have more potential or kinetic energy than another object just simply because of what the object is. The ratio and the percentages work out the same for every type of object. So those we can already throw out. So we'll toss that and we'll toss that. Now we're down to the last two. Okay, so let's think about what you did choose. Potential energy decreases when an object's height increases. And by height we mean distance from the ground. Okay, distance from the ground. So if I take an object and let's just close this, let's give me a little more room over here, and then we'll get our pin back and let's draw two hills. Okay, this hill, put a ball here, we're going to say is 10 feet tall. Okay, now this hill we're going to say is 20 feet tall. And we'll put a ball here. Now based on what you chose, we would say that this one at 20 would have less potential energy than the one at 10. So when they start rolling down, let's see, I'm going to say ball 1 and ball 2. Based on what you chose, we would say that ball 2 would have less potential energy. In other words, it'd be going slower at the bottom and all that stuff. And we know that, and you can imagine based on the diagram that just could not be true. This ball here, if these balls are the same and only the distance is different, this ball is going to be rolling much faster when it gets to the bottom of the hill than this ball, simply because it has further to go for gravity to pull on longer to speed it up at a higher fashion. So if I close this and go back over to our choices, now we know can see that this choice cannot be the correct one, and by elimination this one has to be correct. But let's talk about why. Okay, kinetic energy increases and potential energy decreases when the velocity of the object increases. So in other words, as this object, and let me get that whole picture up in the picture here, when this object is rolling down this hill and the velocity increases, in other words, the longer it rolls down, the more speed it picks up. Okay, it increases its speed. As it goes through here, we've already talked about how the potential energy is going to change, convert into kinetic energy. As it goes further down, it's got more speed, more motion, and the potential energy decreases. So this one is the right one, but I also want to talk about why it's the right one. It's because the further you go down this hill, okay, the more speed, the more velocity it's going to pick up, and we've already demonstrated how kinetic energy increases and potential energy decreases when you're going down the hill. Okay, down the hill. The opposite is true when you go up. When you slow down, your potential energy increases and kinetic energy decreases. So I wanted to touch on that, and let me close this out one more time and bring this one up. Okay, so again, this I didn't bring in the options, but just to show you how to do this one, and then we can talk about the four choices, and then we can pick out which one, because we got the question right here: which object is on the tallest hill? Okay, so we want to know the height of the hill, or the distance the object is going to travel down the hill. So the traditional formula is right here: potential energy equals distance traveled times the mass. Okay, and so, but we need distance. So using our same idea as before, we want distance. We got to move mass over to the other side, and on this side we're going to multiply. So on this side we'll have to divide. So now we simply, all we got to do is take the potential energy and divide it by the mass, and we're going to get the height of the hill. So if we take 980 divided by 50, we get 19.6. If we take 1029 and divide it by 35, we get 29.4. In other words, this is the height of the hill. If we take 1519 divided by 62, we're going to get 24.5. And if we take 1176 divided by 24, okay, we get 49. So the way to spot this visually, the easiest, you pick the one that's got the most potential energy, okay, and that most likely is the one that has the tallest hill. Because if you think about this, okay, the distance traveled, the distance traveled affects the potential energy more than the mass, simply because it's going to be it can potentially be a bigger number. You can see that 49, the distance traveled, is much larger than 24, and we get a bigger number. In this example, when the 19.6, the distance traveled, is less than the mass, then you end up getting a smaller number comparatively in this example. So that's how you work that. You wanted to find distance. Okay. If we didn't know the mass, say they gave us the distance and we wanted to know mass, then it'd just simply be the same thing, except now we're switching the D and the M around. Potential energy divided by the distance traveled would equal the mass. And it just comes down to that mathematical process of, if you want to solve for one variable, you got to move everything else to the other side of the equal sign and do the opposite sign. We were multiplying in this case D and M, and so therefore we have to divide when we get to the other side. Well, Calvin, hopefully that helps. After watching this, if you still need more help or you want more information, maybe more examples or anything, just let me know, and we can either go ahead and set up that meeting. that you guys were looking for, or we can talk in some other way, or I can provide other information and other examples and resources, whatever you need to help you to be most successful. So I'll look forward to hear from you, and with that, we will say goodbye.